Hello everybody, I will start by today another coding session. So today it's of this question, expression add operators. So in this question, I'm giving a string num that contains only digit and an integer target. Return all possibilities to insert the binary operators plus, minus, and or asterisk multiplication between the digits of num, so that the resultant expression evaluates to the target value. I see. Note that operands in the return expression should not contain reading zeros. Operands in the return expression. Okay. So I should return all possibilities. I see. List of strings. Okay. Note that the number can contain multiple digits. Good. Okay. So let me clarify my understanding first. I'm giving a string num, and I will return the list of strings. And this string, each string represents a, mathematical, equation, not equation, but, operation, which includes numbers and plus, minus, or, and or asterisk. Okay, good. And each operand cannot have reading zeros. So let me take a look at some examples. By the way, as a constraint, I try to confirm if it can be empty or target is something like 0. So I mean, given num can be an empty string or not, and I can find here that it cannot be. So I can say this. Okay, good. And num consists only of the digit, not negative or positive operators. Okay, good. So let's say I'm given 1, 2, 3, and I'd like to make 6 from this. So in this case, I will think. I think this I can create it in this way. So this is the first string I should return. And aside from that, this one, 1 plus 2 plus 3. Yep, this is also possible, so I should return this. Okay, obviously I shouldn't include the space here. And also, I cannot use the parentheses. Okay, I see. Good. Okay, so let me think of the algorithm. I think that the brute force approach is that I try to insert multiplication or plus or minus for every, place between 2 digits and try every combination. But obviously this takes so much time. I will try to think how I can do this better. Oh, yeah. By the way, I have to think of another case, something which is interesting, I think. For example, if target is 12, in this case, I can create 12 with this. Yeah. So the operand can be can have 2 or more digits. That's what I have to remember and take care. Okay. So that being said, if I have, say, 1, 2, 3, and target is 6, so because the multiplication has to be done first, let's say I put multiplication, make it more, yeah. if I put multiplication somewhere like this, it should be considered first. Yeah. And also plus and minus, this should be thought later. But the order of thinking plus and minus does matter. So I have to calculate from the head. Okay. So maybe my quick intuition is that maybe I can use kind of dynamic programming. Let's say I have this one later. In that case, I can think of this. Function creates some number, which is possible from 2, 3, 4, 5. Or I continue this and 12 plus f 3, 4, 5 or minus or multiplication, or I can continue like this. Yeah. So that's what I mean by the dynamic programming. So okay, let me go with this intuition. So when I start from somewhere, so the dynamic programming recursive function, in the case of top-down approach, looks like this. So start index and target, this returns Boolean. If I can create the target from the start index of the given string, num. And here at start index, I take this number and take plus or minus the multiplication. So here, let's say, so I just call, yeah. Let's say num si is chosen in this case, or si to si plus 1 is chosen, or maybe si until si to these 3 characters are chosen. In Python, I should write it in this way. Yeah. Because upper bound is exclusive. Anyway, if I take it in this way, I should create this one. So I check something like this. Yeah. And if I take minus, and if I take multiplication, so in this case, I will check if I can create target. No, num si minus target. Yep, I will try to create this one later. And in the case of this, no, this one is a bit more complicated because let's say I create 2 something here from 3, 4, 5. If I choose multiplication and then 4 plus 5, actually this multiplication 2 times is not like this. But 2 is, used only for this 3. So there's a difference from plus and minus case. Oh, and also even true for this minus, because I don't use all the rater numbers like this. If I put minus, it works in this way, not this way. So my line 47 is wrong. So maybe instead, I should pass the should- operator. So in the case of plus, I can just do this. But for minus case, it doesn't work. So if I take negative or multiplication asterisk, I should pass this. Like sign. So this sign can be minus or multiplication. So the number here, with me. If I take minus here, what happens later? Let's say if I take minus and I have 4, 5. There is a possibility that I do this. Yeah, in this way. Oh, by the way, I cannot use this times negative because minus is used for the operator, not as the sign. Okay. So this cannot happen. This can happen, or this can happen, which is a bit more trickier. Yeah. So after this negative, maybe I would take two numbers, or maybe I would take, only single number. And then multiplication continues. So actually this minus is used for this 3 times 4, not only 3. No, but in this case, if I use this negative for here, it does work, actually. Yeah. Actually, it doesn't work as expected. The trickiest thing is, according to what I choose before, according to what follows, this 2 times, so 2 minus, this has different effect. I see. So yeah, but even that being said, my idea is passing this sign. And if I have negative, if this is plus, I can just use this. But if this is negative, I pass this negative as a sign. Yeah. And sorry, what I'm thinking about. So let's say I have something like this. In this case, the first something is used as a negative. So this can be 3, 4 times 5. In this case, this negative should be used only here. 3, 4, 34. Or it can be like this. In this case, negative used for only the first 3. In this case, this negative is used for only the first one. Yeah. So if I pass this sign, the following one just can use this negative for the first chunk and continue the recursion. Yeah. So in the case of multiplication, so it totally depends how many chunks should I take. So in the case of multiplication, the hard thing is these two affect later. Minus can be first, can't come first. So maybe this case, this 2 times affects 3, 4. But in the case of this multiply 2 affect only 3. So I actually have to add not only the sign multiplication, but also the, here 2 factor. Yeah. So that being said, this is more complicated. Mm. Okay. So let me see. My idea is passing that multiplication number as the argument, but if I do that, it will be TRE because I'm just, that number can vary. So memorization actually doesn't work. Mm. Yeah. Mm. Okay, so yeah, multiplication is kind of tough one. Yeah. When I try to do this with dynamic programming, maybe I shouldn't use the dynamic programming and think about approaches, or I should think better at DP multiplication. So from the constraint, num ranks less than or equal to 10. Actually, I can say when I have something like this, in every position, I decide how long the next one continues. Actually, I can try every possible, every possible ranks here because it's up to 10 ranks. Yeah. And also I can think, okay, let's start from 1. I can think of the ranks 1. And also I can try every, operator. If I do this for every ranks and combination operator, it still takes 30, combinations if I'm at index 0. Okay. And if I take this, as I said, this can be done easily. And for this one, I have to pass the positive and negative sign. But for this one, I have to multiply this maybe 6 to the following numbers. It depends how long it is. Wait. Is it possible that I use 34 as 34 between the digits of num? So yeah, I think it's possible. Otherwise, it doesn't say. It shouldn't have the reading zeros. But not clear yet. Let me check. Okay, I could confirm that this is allowed. Right, 34 can be used as 34. Okay. So when I have times here, like this, I don't know how much the chunk ranks should be. Plus, minus, or multiply. Okay, so when I take multiplication, let's think what happens next. I have to multiply something to the first chunk. So I'm wondering if it is possible that I try to find the first chunk in each DP. Yeah, like, no. So let's say I have 2, 3. So, I mean, the definition of chunk is, let's say this, 12 plus, if there is plus later, this can be chunk. Until 12, this is chunk. If I have negative, this can be the chunk. And after that, if I have 3, 4, 5, then minus, this is a chunk. And let's say if I use plus later, this can be the chunk. First, I can say this starts from plus. And if I use, it's hard to understand, but anyway, if I use multiplication, the chunk continues. I continue thinking, And let's say I have negative or plus. That's the end of the chunk. Yeah. So in this way, I can think of the chunk. So if there's a multiplication, I keep continuing inside. I don't stop it and call the recursive function child method, but I keep going. If I choose multiplication here, I continue. But if I use plus, it's there. I call the recursive function here. And let's say I choose minus here. I call the recursive function from here and try to create. Yeah. Because this is 144. If target is 32, I try to create 100. Now, I just can say, yeah, it's completely the freedom, the choice of the child function. If it chooses plus or negative first, I try to create target minus this one. So my idea again is I try to take the chunk and I keep choosing the digit, or if I choose multiplication, I keep continuing. But if I try to insert plus, I would say I finish the chunk and start the next chunk. But the problem here is the target number should be quite specific. So passing the target here, actually with this, the memorization wouldn't work well. So actually I can't. I mean, memorization wouldn't work. So I'm wondering if dynamic programming is a good tool to use here. But anyway, yeah, I think I can use up the chunking in this way. Mm. So if I just use the recursion in this way, it could take so much time because every position I can choose plus or minus or multiply. Which means there are 3 options. So 3 times 3 times 3 times blah blah blah. Which is so huge. Hmm. Wait, I have to return every combination, which means that I actually have to visit every possible, combination. So just doing the math doesn't work because even if I use the kind of smart maths, I can know the number of possible ways, but I don't have that exact possible ways strings in my hand. So definitely I have to do backtracking or maybe recursion to create the actual strings. So the problem here is I have to stop the recursion if I find it impossible to create the string. If I don't do that, as I said, as the brute force approach, I try to insert every possible, operator at every position. And in the end, I find out that I couldn't create the target number and do that. It takes so many combinations, but if I can notice earlier, I have to stop there. I can say this is a kind of trimming, and in that way, I can optimize the traversal. So, yeah, my problem here is how I can stop the recursion or maybe backtracking in the middle. Mm. Let's say I have 15 as the target and I have 1, 2, 3. So, sorry, let me change. Let's say I have 999 as the target, 999. In that case, if I continue plus here, where I do, I, no, wait, maybe I can create 9998 with this. Mm. So the biggest number I can create from this, maybe I should think in that way. Yeah. So if I have some number, if I chunk and do something here, like 8 times 9, it definitely smaller than 89. Yeah, because 89 is 8 times 10 plus 9, but 8 slash 9 can create 8 plus 9 or 8 times 9. In either way, this is smaller than just using it as it is. I'm thinking if maybe this can be used. Hmm. I choose 1, 2, and 3, 4, 5. And also I have the conditions that I cannot use the reading zeros. But let me think of it later. Plus, minus. Okay, so yeah. Okay, so let's implement the wait. 2 to the 10 is how much was it? 1000? Let me see. Yeah, 2 to the 10th is just 1000. So actually, maybe I can try every possible way, like inserting plus or minus or positive multiplication here, 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 here. Yeah, I can try it. Okay. So that being said, what I would do is, as I said, if I have the plus or minus, it's fine. Basically, I use the backtracking and put the string into the current chosen software, yeah, kind of string builder list. Yeah. But for the multiplication, this can be tricky. As I said, I keep choosing the number inside of this backtracking each recursive function in that case. Okay, that being said, let me get started with implementation. This is the start index, and this is the target I'm trying to create. This should be chosen software. Yep. And here, I return this. Oh. So my task in this method find is to create the find the target number, and if I could create it, I put it into the bound list. So if index is the end, and if target is equal to the 0, I can say I could create it. So found expression is this one. And I append it here. Let me change a bit. But otherwise, if index is equal to self.num, I can just return. Okay. Otherwise, from here, try to create the target. And I can choose to take negative first, actually. So I mean, first 3. So what I mean to say is if index is larger than 1, I can use plus or negative. So what I mean to say is 3. So if index is equal to 0, I can use plus only. And I don't append this to child software. So if index is 0, operator should be plus. Yeah. But if index is 1 or larger, I can choose plus or minus. Yeah. But also I have another case I have to take care. If the first one is 0, I cannot continue. So firstly, if this is 0, I return. This is invalid. Yeah. And here, if this is 0, operator should be plus. Yeah. And here, use plus in this case. So wait a minute. What should I do? Yeah, I focus on this part. So if I use plus, I have more choices. How many chars I take as a single number? So that's what I have to take care first here. So end index can be from here to the end of self.num. Yeah. So under here, I don't choose, I don't insert any operator. I can say this is the first number operand. And here I have two choices: continue with plus, multiply, or continue with plus or minus. So obviously, but this is possible if n is not end of the string yet. Right? Yeah. So let's think of this case first. If I choose plus or minus, I just have to continue the recursion backtracking in this way. Minus operand here. Yep, this is it. Oh, wait. If I choose plus first, it's plus. And I continue. And when I come back, yeah, that's it. Okay. Or case number 2, I choose multiplication. In that case, I have to continue. Yeah. Oh, wait. Because I don't use the memorization, now I can pass something here, like previous multiplication multiplier. Yeah. So in this way, if I choose times here, I pass it Where is this? Here. Yeah. Wait, which number choose is completely the option by the following number. So I just have to pass the multiplier. Actually, in this case, this should be 1 because the following one just use the first chunk number as it is. And here, yep. Oh, I passed the operand. So target is as it is. I will treat this later. Oh wait, I said I see. So let me. So in my first approach, I was thinking that if I have the range of the recursive function should be responsible for, I can choose if I put plus or minus or something here in the co-re. Yeah. I follow this approach. And what I can say is the multiplier is some number. Or I should say, I can just call it the last num. No, wait a minute. If I choose it, call it as the last num. If I think of this case, the last number should be -2, right? Should be passed. Okay, so how I can handle this simply? Okay, I see. So I think the caller should decide which operator comes next. So if I choose negative here, what I should pass is -1 times some number. If I choose multiply here, this means I should multiply 12 to this number. And this 12 should not be counted at this moment. If I choose plus here, after 2, I can think of this as 12 is counted now. I can write it in this way. Yep. Okay. I could simplify this. What I have to choose here is how many numbers should I take as the, first following number, first chunk, and then I decide the operator. Okay. So let me change a little bit. So firstly, I should pass 1 as the multiplier. because firstly, it means I chose plus. Okay, that being said, here as the edge case is a bit confusing because if I choose plus or minus or multiplication, whichever number I choose, no, I mean, so, oh, wait. I have to distinguish. Let's say, actually this 12 is the end. What happens is, actually this is nothing. In that case, how should I treat this, you know, 1 times, negative 1 times, 12 times? So here, I should treat it as 0. Yeah. And for this, it should be 0. Oh, sorry. How about this case? In this case, I should treat this as 12. I mean, because I have to take this f something as 1, because 12 is still there. I actually have to distinguish this 12 and 1 here. Yeah. So what should I do? Or another approach I can take is I will think of the base case in the coder. So I will assume that this index is less than length of nums. That being said, I can choose at least 1 digit here. Yeah. Okay, let's go with this. So I can choose at least 1 following digit. That being said, here, so if this index is 0, I have to return because this is the, reading 0. Otherwise, I can choose end until the end. Yeah. Or, no, yeah. And here I have 2 cases. This case or later. So if this case, this is the end of the string. So I can say, oh, and either way, I can take operand in this way. So this is the operand. So this is the end. So yeah, so I can just add this operand times multiplier. If this is true, yes, I could create the target number. So expression is wait. If I choose the end, I have to append this operand to save the charge software. Actually, I can append this operand as a string. Each element doesn't have to be a single character. Yes, I do it in this way. Wait with me. So this is string, so I convert it to. Sorry. Let me just do it in this way. Okay. It doesn't matter how many times I convert, actually. So I append this, an expression is created. Then I append this to the found list. And that's it. Okay. Otherwise, I can continue. So I have the operand here. Oh, and I choose 3 cases. This, or this. So in this case, my task is to create the wait a minute. So this operand is actually evaluated at this. So my task is to create target minus this one. I try to create this. N plus 1. And I try to create this one. And multiplier should be, because I choose plus, it should be plus 1. Okay. And if I choose minus, multiplier should be negative. And if I choose multiplier, I don't evaluate the operand here, but I pass the operand later with the multiplier in this way. And I continue. And also I have to update the charge software. This operand is already added, so I have to append plus here. Then after coming back, I have to pop this out. Okay, I have this. Okay. And actually, I append operand here, so I have to roll back this 2 after the whole operation. Oh, or wait, yeah, right. Here, I have to roll back. So this one is rollback here, here. Good. Yeah, that's basically it. Okay, so for today, let me skip the dry run and let me submit. So here. This should be -1. So expression is created here. Oh, sorry. So this should be added here. Seems like expression is saved. Okay. Oh, accepted. Let me submit. Wrong answer. So 10 minus 5 is created, but in this case, 1 times 0 plus 5 is not created. I see. Okay. So reading 0 treatment. So here, I immediately rejected it. But actually, if this is 0 only, it's fine. So here, if operand is equal to 0 and index is larger than start index, so in this case, this has the reading 0, which is not just 0. So in this case, I continue and I read this. So I try with this failed case. Oh, no. So operand is, wait a minute. So operand, even if the operand is not 0, let's say it's 0.5, it's not okay. So I can say if self.num index is equal to 0, the first one is 0, and I chose longer than 1 character. In that case, it's the reading 0. Okay, good. So let me submit again. And accepted. Great. Okay, so let me quickly wrap up. So today I saw the question, expression add operators. And firstly, I thought this is a dynamic programming question, but actually it wasn't. I could find it because I had to return all the possible string, which means that I have to visit every possible, combination, every possible choice. So maybe I can use the dynamic programming, but just the recursion is accepted definitely, because in the end I have to create each string, so I have to go through each choice path. Yeah. And that being said, I used the backtracking in this question. Okay. So in this backtracking, I passed the multiplier as the recursive function's argument. This is something outstanding in my approach, I think. And from each start index, I chose how long it is and what operator should follow after the operand. Then I continue the backtracking with each case. And the case I've overlooked is the reading 0. And yeah, so this can be found in this logic. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.